Good evening, ladies and gentlemen, and welcome to Eastham Public Library and the continuation of our series of talks on ponds. I'm Jim Bachman, one of the volunteers here working on programming. For those not familiar with the library, the restrooms are in the hall right out here, and there's a water fountain. The emergency exits are in the corners behind you and left front. Hearing assistance is available in the back if you need that. And first, a big thanks to the members of our Cape Cod community, including this evening's speaker, who have generously given of their time and considerable knowledge to make possible programs like this one. Often, of course, our speakers aren't free, and I'd ask you to consider joining the Friends of the Library to help support our other programming. Here to talk about the communities of critters of all sizes in, on, around the ponds is Sophia Fox. She does research at the National Seashore to better understand and predict what's going on in our fresh and saltwater systems in terms of water quality, biological processes, and food web interactions. She's an ecologist specializing in the aquatic environment and has been at the seashore for almost 10 years. After picking up her PhD from the BU Marine program in Woods Hole, following her talk, we will ask her to answer questions. So here is Sophia Fox.
Thanks for coming, everyone. Thanks, Jim. Thanks to the library for having this series. These are great opportunities for us all to get together, so I appreciate you all being here tonight. So the title of my talk is Mallards, Mollusks, Mosquitos, and Mud. I hope that I'm going to give you a slightly unique perspective on these things. Well, I'll just get right into it. So, as you all know, I'm here to talk about ponds. This is one of yours. Oops. And the pond life. But before I do that, I want to impress upon you a couple of ideas and concepts that I'm going to carry through in this talk. So just to go through here, we have our microorganisms, our algae and small zooplankton, our insects primarily down here, copepods, fish, these are herring, our mallard ducks, osprey, which love to eat herring. But what I really want to impress upon you guys tonight is that our ponds don't sit in a vacuum alone. They sit in the landscape, and that is something that many of you are very familiar with, the impacts of the landscape on the ponds. And so I hope to talk to you a little bit about the pond landscape, the pond ecosystem, and some of the work that we're doing looking at the relationships between them. So the landscape, when you think about it, includes the pond waters, the pond bottom. I had to make one here. Nobody likes the mud. The surrounding terrestrial ecosystems, our homes, us recreating. That is the whole landscape, and even the atmosphere. So when we think about our ponds, we need to think about them at many scales. This is just a little cartoon of some of the different scales that we think about. Everybody knows the individual fish swimming around, but that individual is part of a population. That population is part of a community of organisms of different species. They're part of an ecosystem. And then our ecosystems sit with other ecosystems. And then they're all part of this biosphere, or what we kind of think of as a region or an area that comprises all those components I was just talking about. The waters, the surrounding lands, the atmosphere, maybe even some development. So on Cape Cod, we care a lot about our ponds. We have over 1,000 of them. Cape Cod, southeastern Massachusetts, even out in Long Island. Those are the main places where we find kettle ponds as we know them. And so they're fairly unique in terms of the globe, these environments. So we're really trying to take good care of them out here. And so you can see they're dotted along the Cape. And here's where we are up in here. And we've got a bunch of ponds right around us. This library is situated in a beautiful location right on Depot Pond. So here we are. Actually, I think this picture is actually before the new library addition. Eastham is a coastal landscape, and these ponds that we all care so much about sit in the coastal landscape. They are coastal ponds. And they sit amongst a great land of development and human activity, and that's the context that I want to talk about them today. So as many of you know, the ponds are depressions in the earth formed by glacial ice blocks that were left behind with the receding glacier, and then the water table filled in these holes in the earth, and that continues to be the way our ponds exist today. So they are an intersection of our groundwater aquifer. As they've been here for some time, they've developed their own unique environments, they've sedimented their bottoms, and they continue to interact continuously with our water table. In many cases, as we learn more and more about our ponds, we find that some of the water moves in through the groundwater into our ponds, and others goes right under them. And with that water, we all know, it brings with it some of our nutrients that we produce on land, nitrogen and phosphorus, primarily through wastewaters and fertilizer. So I'm going to go quickly through the nitrogen and phosphorus cycles in a pond. But essentially, we have an inflow like this from the landscape of phosphate and nitrate primarily. And those get taken up by the algae and the plants in the pond. And then as those things die, they settle out into the bottom and they become part of our mud. They decompose, they get decomposed by microbes, and they get taken up by our plants. The nitrate can also be used by the phytoplankton. It can also be denitrified to nitrogen gas by bacteria. And so all these processes are going on the bottom of our ponds, on the surface of our plants, in our algae. And then this is an absolute requirement for life in our ponds. As many of us know, some of the connectivity to the landscape, the hydrologic connectivity can produce conditions where the nutrients become in excess, and we end up with algal blooms or an excessive amount of plant material in the ponds known as eutrophication. And that's an issue that Eastham has definitely faced and is facing. So back to our ecosystem. So I stole this picture, so it still has its things, but I thought it was so pretty that I kept it. So this I thought was a really great depiction of what we're talking about in a pond, and it really captures many of the different components, although it left out the mud again, which again, as I said, is really, without that component, the pond really wouldn't function. So that's biogeochemistry is one of my areas, so I always get a little offended. So our plants are taking up our nutrients from the mud and from the surrounding waters, as well as algae, which are not depicted in this one. And then those things are eaten by our grazers, and that moves around in our food web. And what we call that is energy connectivity, or also known as the food web. where we have the energy that's produced from the sun by our plants and algae moving up into the grazing communities. So we've got things like snails that graze. We have zooplankton that are grazing on algae. This here is a beautiful caddisfly larvae that builds its shell out of debris on the bottom, builds its home out of debris on the bottom. And those are all feeding directly on our plants and algae. And then those contribute an important food source to some of the larger insects, and our mallard duck, as in the title, who's an omnivore. The mallards will feed on both the algae and plants, as well as the insects and mollusks on the seafloor, on the pond bottom. And then all the fish and larger organisms like frogs and birds fall at the top of our food web, going up to an osprey there. I even watched, on Gull Pond, I saw a bald eagle eat a trout. So that was one of the highlights of my life. It was from my living room, even better. So if you're somebody like me, you start wondering how all these pieces fit together. And so I'm going to sort of talk you through this. So at the very bottom, we have our bacteria. They tend to live in our sediments and on the surface of our plants. They're absolutely critical for creating the nitrogen and phosphorus that these organisms need and cycling them. But we also have us contributing nitrogen and phosphorus to these systems from the landscape. These get taken up by our algae, our phytoplankton, as well as our plants, which then, as we follow the arrows, get the energy from these producers that they're gathering sunlight and nutrients and passing them up the food web, because we can't gather sunlight and nutrients that way. So we need them to move them through the food web. So our zooplankton goes into some of our fish. Snails are feeding on algae, the attached algae, and everything starts moving up to the bigger things. And so those arrows are what I spend most of my time on. So again, I want to really emphasize that vegetation and algae are absolutely critical to a healthy pond ecosystem. As I mentioned earlier, you can have too much of a good thing, but if we didn't have these plant communities on the shorelines of our ponds, and these algal communities in these ponds, nothing else would be there. They would be devoid of life. So this is absolutely critical to our ecosystem. These producers, the algae and plants, feed all the grazers and omnivores. They provide the bulk of biomass, we call it the food in the system. They are what everything eats. And even if you don't eat them directly, you're eating the nutrients that they've provided to the organisms that you eat. And this is another beautiful picture that I found of the pond food web really going down to the base of it with these small organisms. So these will be some of the most abundant organisms in our ponds. These things you hardly ever see. Most of them live in the mud for most of their lives. I've been bit by a bunch of these. So that's a mosquito larvae there. I'm not sorry, not mosquito, a dragonfly larvae. And then, of course, they become these guys. And these are absolutely critical to the function of our ponds. So the larger fish, birds, mammals, frogs, amphibians, all these predators rely on these abundant food sources at the bottom of the food web. The things that we don't pay much attention to, or the things that we don't even really like that much. They're absolutely responsible for creating this image. So in Eastham, we're fortunate to have many ponds on our landscape. And our landscape is quite diverse. We have some areas of our landscape that are in conservation land. We have some areas that are very heavily developed along our ponds. And these watershed uses have a big impact on our ponds. In addition to what's on the landscape, we're one of the biggest things on our landscape. And here, we all know that our ponds provide enjoyment to many, many people, and that enjoyment leads to the ponds experiencing significant use. And these are just a couple of examples of what happens when we interact directly with our ponds. What we can see here is that this is a beach devoid of vegetation. We don't like vegetation very much. We don't like to wade through it. I was afraid of it as a kid. Now I spend my time in it. And we like to pull our cars right up to it, jump right out, line up, and spend the day there. So these are all things that we all will continue to do, must do for our own well-being. And so we're all tasked, sort of in my world, with balancing this type of use with the health of our ponds. And so we definitely try to maintain as much of this type of character in a pond as possible, and restrict these areas where people can access and remove vegetation, understanding that this is an absolutely critical use as well. So some of the other things that we see, these are all in the seashore. We see a lot of erosion, and we do a lot of work to correct erosion in the seashore. Where people walk along the shoreline of a pond, we get lots of trails where the vegetation has been removed just from trampling. This is Gull Pond from the air. You can see these are trails out from people's homes. So pretty much every house has a trail. So these are all things that we pay attention to, because if we start losing too much of our vegetation, then we know that we're significantly impacting our resources, and we might be significantly impacting the rest of the communities that live there. That is the insect and fish and animal communities. And then this connectivity expands beyond Eastham, it expands beyond Cape Cod. We're connected to the region. And we're connected to our atmosphere. And some of you, I think, in this room, I may be showing you something you've seen before, but I'm going to talk to you about some of the research we've done and published in recent years, really showing how connected our ponds are to the region. So we know that the surface temperatures of the Earth have been increasing. This is an image of North America. And what we see is that here in New England, we're actually increasing at a much higher rate than the rest of North America, or I would say the rest of the United States. And it's pretty significant. The difference between from us, this is the difference to the average. So 0 would be average, where about 1.25 to 1.5 degrees Celsius higher than the average. So that is substantial and something that we're paying attention to. What some of the predictions are saying about what this looks like is here we are up here in Massachusetts. Actually, we're not, though, because we've already started looking like what New York looked like about 20 years ago. So we're already starting to look more like a southern state. And as time moves on and we continue warming, we're actually looking like we're in this red higher emission scenario right now, that by 2040, we might be looking like Virginia. And then as we close out the century, we're going to be looking a lot more like South Carolina. So these are all things that, that as scientists, we're paying attention to. What's that going to mean for the landscapes that we're trying to preserve and understand? And we're really watching it happen before our very eyes right now. The other major change that we've seen from the atmosphere are that there have been emission regulations under the Clean Air Act, which have reduced the emissions of sulfur oxides and nitrogen oxides from electric power plants. And what we've seen is that there's been a significant reduction in these emissions from power plants since the Clean Air Act was enacted. And we've seen this also just in New England power plants. So we were interested in knowing, well, what does that mean for Cape Cod? So we set out to do a bunch of research, and these are some of the publications that have come out of this effort, looking at how these atmospheric changes and changes in temperature are affecting our ponds. And one of the big things that we noticed was that the changes in the atmosphere are measurable in our precipitation. So this is precipitation data that was collected in North Truro at our National Seashore site. We're part of the National Atmospheric Deposition Program that's been collecting data since at least 1980. And what we did was what we do with that is we collect the rain and then we analyze it for different parameters that are related to features of the atmosphere, particularly looking at the impacts of acid rain. And so in the 80s, acid rain was a really big deal, and so they really focused on this program, and pH and these emissions from power plants were the major factors that were related to the acid rain problem that we had across the Northeast. And what we've seen is that in the early 80s, the pH in our rain was quite low, about 4. Over the last several decades, it's increased to around 5, which 1 pH unit is about 10 times less acidic. So that's a big deal if you're an algae or an insect. And the same is true for the sulfate and the nitrate in our rain. We've seen declines over that period with the Clean Air Act. So we know that the rain falling on our landscape has changed. So what does that mean for our ponds? In addition to the precipitation, we know our temperatures are increasing. These are our local temperatures. We did a big analysis to find out whether our temperatures were actually increasing here. And what we found was that in general, the maximum temperatures in summer and fall haven't changed really at all. But what we have seen was that the minimum temperatures have increased since the 70s. So it means that our low temperatures are not as low as they used to be. So, you know, if you're in a single day, your high might be exactly the same, but it's not getting as cold at night. And those things really matter if you're a pond. So what are the impacts? So we've been out on the ponds since the 70s, collecting a whole bunch of data. And we're lucky because we have actually one of the longest water quality data sets on freshwaters in the United States. And so we were able to use this data to really understand what's been happening as these changes in the atmosphere have occurred. So this is done in all 20 of the seashore ponds, unfortunately not in Eastham ponds. And what we've seen is, here's a few of our ponds. The pH has been increasing, and the sulfate has been decreasing. And this is the precipitation data, just to show you. So it's following the precipitation data pretty closely. And actually the relationships between them are very strong, and Those are in the publications that I showed you. In addition to recording what's raining down on us, in the precipitation, in the water of our ponds, we're also recording it in the sediments of our ponds. So this is a figure, this is a sediment core from Snow Pond in Truro, in a little tiny, unobtrusive pond. This is the present, going back to about 1500. And this is the concentration of these different metals in the sediment core. And so as we go down in time, we're going down deeper into the mud. And what we see is that the concentrations of these elements, these metals, in the 1500s were quite low. We saw a little peak here, but what we saw was when the Industrial Revolution started, they started increasing. So as we started using metals and putting them into the atmosphere, they began depositing on the landscape and on our ponds here in Cape Cod. And so we can measure them in the sediments. Here we can see the automobile come in and lead starts increasing. And then here's where unleaded gasoline started, no lead. So we can trace the record of human development in the mud of a pond in Truro. So connectivity, we are not in a vacuum. Everything that goes on around us is being recorded in our ponds, and this has a big impact on these little organisms that are absolutely essential to life in our ponds. So those of us who have lived on Cape Cod for a while have seen some of the impacts of climate firsthand, a lot of coastal erosion, a lot of storm activity. As I've shown, we've measured increases in air temperature. And one of the things that's being predicted as well is the increase in storm frequency and intensity. We aren't sure that we've seen that here exactly, but it seems to be on the horizon. And the increased occurrence of summer drought. And these are all factors that would have major impacts on our ponds. So the higher air temperatures might have higher pond water temperatures, and they do. Changes in storm frequency and intensity would be more precipitation and more wind, which would alter the pond water temperatures, increase pond water levels. If anybody's been out there this year, these are the highest pond water levels that I've seen. Increasing our shoreline erosion and decreasing the clarity of our ponds, which is something that we worry quite a lot about. More summer drought would increase our pond water temperatures even more and decrease our pond water levels. And so we were really wondering what is going on in our ponds. And what we found was that as the air temperature, there's a really close relationship between the air temperature and the water temperatures in our ponds. So whatever's happening up in the air, out in the atmosphere, is happening in our ponds. We have no doubt now. This is about as good of a relationship as you could ever want as a scientist. And what we found is that over the period that we analyzed, the temperature in the water in our ponds has increased between 2 and 5 degrees Fahrenheit on average, which is a huge amount, especially if you're a small organism. In the period prior to that, it really hadn't changed at all. So this is a big change. So we know that our ponds are warmer than they used to be. And so that's going to make a big difference if you're a plant. Plants have ranges of temperature tolerance. Different plants tolerate wider ranges than others. Some algae will be really happy to grow at a higher temperature and will outcompete others. And so we'll find that there are all these shifts in our communities. And many of, as I said, these ponds in general have been fairly constant for many decades. And so the organisms that are there are accustomed to a certain plant or a certain habitat or a certain way of life. And so we're rapidly changing that way of life on these organisms. And so some of them are disappearing. Unfortunately, locally, we don't have a lot of information on who's where and what are these populations at the level where we could say that something's gone that was there before. We unfortunately haven't done that, don't have that research in our pockets at this point, but it is something we want to do.
You mentioned eutrophication. Do you have studies about phosphate, changes in phosphate in the last 30, 40 years?
So most of the work that I've done has been in the seashore, and we have not seen a change in phosphate in the seashore. So in areas where development has sort of halted for the most part, the phosphate has been low and constant. In places that have become developed across the Cape, phosphate is increasing. We also know from research that we've done at the seashore and others have done that combining nitrogen and phosphate in a pond makes it even worse. So we know that the conditions in many of our ponds with excess nutrients have led to eutrophication, and many towns and other entities are working on addressing that issue, both in the short term with treatments like alum and others, aeration, that kind of stuff, and in the long term with really addressing the phosphorus reductions as well as the wastewater management. The treatments that have been undertaken so far really are short term. They're kind of a quick fix. They're not a long-term management solution, and regionally the long-term management solutions are underway and being talked about, and they're not only impacting our ponds, they're impacting all of our coastal waters. So it's a major issue that we're all dealing with, and there's a lot of people who are involved in understanding what the best solutions might be, and how we can be creative at finding solutions. There's a lot of great ideas out there and a lot of stuff being tested, so I think there's a lot of hope on the horizon. Yes?
Yes, I had a question. You were showing the pH level and how it changes over time. It seems like over time, the ponds have become more basic. In other words,
Less acidic.
we're not, acid rain is going away, I guess.
Acid rain has gone away, yeah. That's right. That's right. Because the emissions from the power plants have been reduced. Yes? Hi.
In the slide before this one, you showed temp. Okay, I just wondered what time of year you.
This is summer.
This is summer?
Yep. And we actually have found that the temperatures are increasing more in fall than at any other time of year, which is also what we've found with air temperatures. So the air temperatures are, the lows are higher in fall than at any other time of year. Yes.
Were there any characteristics that led to 2 degrees of change versus 5?
I don't know the answer to that yet, but I can tell you that of the 10 ponds that we included in this analysis, there are differences. Each pond is a little different. You kind of have to treat each pond differently. It's not really across the board. It's not size, it's not watershed development, and even eutrophication isn't necessarily related to the factors you might expect. So it's been interesting. Each pond is their own individual. Yes.
I heard that some ponds are experiencing algae blooms. So what effect does that have?
So algae blooms would be the result of the excess nutrients that I was talking about, primarily from human uses. And what tends to happen when there's a large enough bloom is that the oxygen becomes depleted in the pond. And once you don't have oxygen, it's a hard place to live if you're anything other than, even for algae, it ultimately becomes toxic. So most organisms require quite a bit of oxygen to survive, and the ones that aren't able to move out of the low oxygen areas do end up dying, and some of you may have experienced a fish kill or something like that. That would be the result of low oxygen from the algal blooms. And usually with an algal bloom, you also have a bacteria bloom and other things that are using up the oxygen in the water. Yes.
The sediment data, would that reveal the pH level or basically the pH level pre-industrialization of the water?
So there are ways to do that. Usually you have to use some sort of fossil or some sort of tracer in the sediment to do that. I do know that there has been some work to retrace the eutrophication history. I don't know about pH specifically, but you can trace the eutrophication history, and that's how they've understood succession of ponds. So ponds have a succession, a natural succession from the day they were formed. They are forming sediment and kind of filling in slowly. And so eventually, in the geological time scale, most ponds will fill in and become part of the terrestrial landscape. Yes.
When you take these measurements here, do you always make sure you try to get my same depth?
Okay. Okay.
I'm sorry?
Microphone.
I was curious, when you take these measurements, do you make sure that you're at the same depth? And would the average depth of the ponds that you measure have any impact on whether it's a 2-degree increase or a 5-degree increase, or is that sort of normalized out?
It's normalized out of these data. We've dealt with that in these data. We sample, every time we sample at the deepest point of a pond, and we take a profile from the surface to the bottom every meter. And this data selects out a portion of that water column.
When I go by the ponds near the visitor center on the bike trail, and I see lots of lilies, water lilies in the ponds, is that good or bad? Are the ponds healthy when you see so much of the pond being taken over by these water lilies? Should I be smiling or frowning?
I would smile. I would say smile. So the more, so like Button Bush Pond, I think is right next to the visitor center. Those are very shallow ponds, not what we think of like with Great Pond and Depot Pond. So those ponds have more vegetation that can emerge from the bottom, so you'll see more of it. Whereas in these deeper ponds, you can only see lilies, the first few meters from shore, because then it's just too deep. They can't reach the surface, so they can't live there. So it's not a bad thing necessarily. However, there are conditions where too much vegetation is the result of eutrophication. But you tend to see more of an algal bloom or something associated with the plants, with the emerging plants, when you have an over excess of nutrients. Yes.
I have a question. Are you at the point where you would like questions?
We can have questions, that's fine.
Okay. My question was that a number of people have told me on some of the larger ponds that there's been a noticeable decrease in vegetation over time, so that people are getting concerned about it. Is that in fact a trend? If it is, I take it that's not desirable. Are there things that should be done or can be done to slow that trend? And should there be any, or is there any effective way to replant, or should we be addressing that?
Most of the places where there is a lack of vegetation, it is usually because there are people there. So that the vegetation can't grow because there's too much disturbance in the soil. That being said, the shoreline vegetation that is in our ponds here in the Outer Cape is made up of a very specific community of plants that live at this edge of the pond where sometimes they're in the water and sometimes there's not enough water for them to grow. So the shoreline of the water is always moving from year to year, so you can't be a plant and expect the water to be there. And so in the low water years, you'll get different plants than in the high water years, because the high water years won't be the right environment for some of those plants and they won't germinate and grow. So the fluctuating shoreline of the pond allows for a diversity of shoreline plants to exist in our ponds. So we actually have some of the most diverse plant communities in ponds throughout the region that I was talking about earlier, because they are, for the most part, allowed to grow. So in certain water conditions, you might have conditions that aren't favorable really for the shoreline plants to be successful for whatever reason. Whether it's just too deep where the seeds are, or some germination didn't happen in that area so well because of the conditions. And so that's definitely possible where the right plants weren't there for the water conditions. And then as far as, they're definitely important to be there. If they're not, I would expect that in those conditions that in another year they would come back. So they wouldn't be gone permanently as long as the favorable conditions returned in a reasonable amount of time for the seeds to still be viable.
Yeah, specifically this was in reference to Great Pond, I guess, where there's a lot more human activity along the shorelines. With a decrease in activity, the plants would come back.
That's right. Yep. And that's what we've seen in a bunch of the seashore ponds.
No, Great Pond has had a alum treatment in 2014.
Yes.
Does that relate to what you're talking about?
So the alum treatment doesn't directly impact the plants. It doesn't directly kill things. But it changes the environment in which they're living. So as one of the main features of an alum treatment is pulling all of the mud out of the water, all of the sediment out of the water, and then allowing it to sort of fall to the bottom. And so it has a burying effect. So a lot of plants and their seeds get buried by an alum treatment. So I don't know, I would say I don't know of any direct relationship where there's been an alum treatment and the plants disappear. Generally, the conditions that lead to an alum treatment, post-alum treatment, the conditions are improved. So the conditions were so bad that it needed an alum treatment, and so you have an improvement. It may take a couple of years for things to sort of come back and find their way again, but they do.
Do you want to finish your talk and then have
What
questions?
time is it? It's the clock. Yeah, I'll talk for a couple more minutes. So as I was saying, this is a depiction of that shoreline plant community. So there's the plants that live on the land but like to have their roots wet, so they like to live on a shoreline. There are the emergent plants which grow where it's shallow enough for their plants, their leaves to reach the surface from the bottom. And then there's these floating plants like you were talking about, the lilies, so they can grow a little deeper because they throw up these long stems. And then there's submerged plants in our ponds up to a certain point, and then many of our ponds are so deep that no light even gets to the bottom and no plants can live there. So, so this community is really dependent on the location of this water line. So if this water line kind of moves down, some of these plants may not be able to survive. So you might have a year where the plants that like to have their roots wet aren't doing so well because where they like to live is no longer wet. Or you kind of start eliminating different species as the water levels move around. And so this does, though, as I mentioned, does allow for a diversity of plants on our shorelines. This changing environment allows for many different plant species to find favorable conditions and live. And plants are also temperature sensitive, so up to a point, most organisms, including plants, will grow better as it gets warmer. You know, they don't like the cold, so it can get warm to a certain point, and they'll grow faster and greener, you know, all those things. But then at a point, it becomes a problem for them. It becomes too hot. Their seeds won't germinate. We don't think we're at that point for really any of the plants. Unless, of course, they are dry for too many years, where they can't emerge. So we do know that phytoplankton will like it warmer for a little while. They'll like a 2 to 5 degree increase in temperature, and they'll probably like it even more as it increases a little more. As these guys start not liking it, these guys will keep liking it, and so that's a concern for us. Because these are the ones that will turn our water columns green, and we'll see a decline in water clarity. And it will be dominated by just a few species, like we see in our macroalgal blooms. You'll see just a few species dominating, and then there may not be the appropriate grazer organisms for those species. So these are the concerns that we have as we move forward. The temperature could drive eutrophication, even under lower nutrient conditions than we've known before. So again, these are the plants we're talking about. We've got the emergents, the floating plants, and then the plants that like their feet wet. So pond water level is really important, and so as we move through this climate change, we'll be watching all of these things. And anything that happens down here is going to move up. So we don't know specifically how or who's going to be affected by, you know, this species being driven out, but we do know that somebody probably will be. The question is, are they so important that they knock out an arrow on our food web? Or they knock out an arrow down here, and an arrow here, and an arrow up. So one change down here, or a big enough change down here, can move all the way up. So what else? How many of you know about pond stratification? All right, good. Well, I'm going to tell you. One of the things that we know is happening is that the higher pond water temperatures are altering the length and strength of the pond layer formation in our ponds, known as pond stratification. So ponds stratify in summer or late spring, and they stratify because the surface of the waters become warm. As the air temperatures warm, as we move into the warmer seasons, the sun heats them up, the sun becomes higher in the sky, they become warmer than the lower level layers of the pond. And the stratification is formed based on the density principle that cold water is heavier than warm water. So basically, the warm water on the surface is separated from the cold water on the bottom. This is sinking all the time. And then there's an intermediate layer where they mix. But this situation of pond stratification creates a situation in almost all of our ponds, even ponds that aren't that deep, where the waters at the surface are separated, the waters at the surface are separated from the bottom waters, and the waters at the bottom are separated from the oxygenated air at the surface. And so the bottom of our ponds becomes low to no oxygen for a large part of the year. This is a natural occurrence that happens. That period of stratification, though, is generally not very long, so that it doesn't have a major impact on the pond. But what we're seeing with warmer air temperatures is that is changing. And so pond stratification really has an impact on the plants and animals that rely on oxygen, which are all of them, where there's high oxygen in these surface waters and low oxygen in the bottom waters. As I mentioned, we go out to the middle of the pond and we lower our instrument through all these layers to take measurements, and we take measurements every meter. Our deepest pond in the seashore is 22 meters, which is about 65 feet. I don't know about how deep the East Ham ponds are, but even some of our smallest ponds are 65 feet deep. So the size of the area of your pond does not determine how deep it is. That size of that ice block does. So pond stratification is a seasonal thing. In the spring, when we go out and take our measurements, this is the temperature and the depth. So we're sitting up here in our canoe, dropping our instrument down. The temperature in the spring is the same from top to bottom. Then as the surface starts warming up, here it's 17 degrees C, nice and warm. You start warming up those bottom layers, top layers, and the bottom layers still remain cold, around 10 degrees, with this big mixing area in the middle. So there's some oxygen in this mixing area, no oxygen down here, and plenty of oxygen in the surface where it's getting oxygen from the air. So essentially in the early spring, you've got a well-mixed pond, fully oxygenated. Late spring, summer, into early fall, you've got cold, low oxygen to no oxygen bottom waters, light, warm waters on top that are full of oxygen. And then in fall, as the surface waters get cold again, what happens is there's what's called fall turnover. And what literally happens is the surface waters start getting cooler and cooler and cooler, and they start sinking because of density, and they flip over the pond. And so it's called turnover. And then it becomes well mixed again. So this is just an example of the data that we collect. We go out every 2 weeks from spring before stratification through fall turnover, and we take these profiles down into the pond. And so all of them that go like this are during stratification. And here's just an example of the spring, same temperature throughout the pond. Summer, this is August, so we've got really warm surface waters, a mixing layer, and really cold bottom waters. And then in November, it's fully turned over again. So we hypothesized that increases in air temperature, so warmer surface waters for longer, would have a longer stratification period. There are some of my interns taking measurements. And that's what we found. What we found was that this SS is a measure of the strength of the stratification, so how hard it is to get it to break, how hard it is to get it to mix. And then this is the difference between the surface and bottom water temperatures. And so what we've seen over this period of warming is that the strength of our stratification, it's getting stronger and stronger and stronger, so it's harder and harder to break. And the difference in temperature between our surface waters and our bottom waters is greater than it was. So in the 90s, it was 5 or 10 degrees C, and now the difference between the surface waters and bottom waters, and now it's 15 or 20 degrees C, which is almost unbreakable. So the surface waters have to cool down quite a lot more to create that turnover and bring oxygen back to the bottom. And one of the problems that occurs as a result of that, our nutrients get released from our sediments. So we know we have nutrients coming in from land that are feeding our phytoplankton and our plants near shore. But when this low oxygen condition is happening down here in the bottom waters of our ponds, the conditions are right to release phosphorus from the sediments. So phosphorus that's been settled out from decomposing organisms, has been sitting there and has been buried until it encounters this low oxygen water, and the conditions are right for bacteria to, actually it's not even necessarily bacteria that do it, for it to get released back into the water column. So we see these big releases of phosphate during these low oxygen conditions. And so the longer they persist, the longer that sediment that has all this phosphorus in it is allowed to release it. And then when the pond mixes, it spreads it all throughout the pond. So that's something that we're concerned about, is that we may not be adding as much phosphorus anymore to the ponds, but it's there in the sediments, it's been buried and only accessible during these anoxic periods, these low oxygen periods. And if those periods are getting longer and longer and longer, then that phosphorus has a longer avenue to get into the water column, where it can be doing harm to our ecosystem. And even worse than that is this stratified condition makes the pond a difficult place for our fish and other organisms. So here's the winter condition, assuming that the fish aren't resting for the winter. Where the pond is fully oxygenated, fish can go wherever they want. In the spring, it starts getting less good on the bottom, a little lower oxygen, and fish are kind of moving away from the bottom. But as we move into the summer and we've stratified, almost no fish can live in the bottom because there's no oxygen. Very few fish even like the surface because it's too hot. Fishermen know that. It's not great fishing in the summer. And they're all stuck in this little band of this mixing zone. And so all of the organisms are crowding into a smaller space. And if the conditions at the end of the season tend to be the worst, where you have the warmest surface waters, and these bottom waters have been separated from oxygen for so long, if that length of time is extending further and further into the fall, this condition, where this is the only livable portion of a pond, that's going to have impacts on our higher trophic levels especially. And then relief will come at some point, hopefully, and they will begin to turn over. So warmer temperatures will have longer stratification. we're starting to see this in our data, that the stratification is going later and later into the season. I'm gonna skip that. So to summarize, pond ecosystems are complex. They're closely connected to the surrounding landscape, whether it's the immediate shoreline or the atmosphere and things that are going on way far away from Cape Cod. The plants and algae are absolutely essential, so we want to keep them happy. Where there's an excess of nutrients, we do see blooms, but there is a balance that we need to strike. The insects are the base of our food web that are really feeding everything bigger. So they need to be promoted, and their habitat is our emergent plants. So as far as the climate, the changes in pond biological structure, phytoplankton and shoreline plant biomass and community structure is changing. And we know that changes in the food web relationships are occurring. Nobody's measuring them though. And it's happening in both directions. So the plants and the algae are changing their communities, and that's moving up, and the fish and the larger organisms are being impacted, and that's also moving down the food webs. So there's a lot of stuff going on out there. And we're hoping that we're getting some money to start looking at the cyanobacteria, which is something that we haven't had the funds to do. Changes to the physical structure are really where this is all happening. The waters are warmer, stratification is longer and stronger, water levels are more variable. We're seeing more shoreline erosion that's exacerbated by human uses, and we have some places where we're seeing a decline in water clarity. So we all know kettle ponds are critical natural resources. We all love them. That's why you're all here. They're changing a lot in response to local and atmospheric changes. And everything we know is because of the monitoring and research that we've been doing for decades. And we are a big piece of the change that's going on at the local level. So, thank you.
Possession is 9/10 of the law, so I'm going to ask a question. When the weather changes in autumn and the pond flips, and 3 weeks later there's Indian summer, how long of a period of Indian summer is harmful to that process?
So the sun has gotten fairly low in the sky at that point, so it's really hard to generate the heat over a long enough period to create stratification again. If you get it, it's only very close to the surface, so it won't happen again. Yes?
Yeah, so you showed data that associated decrease in sulfur and nitrogen oxide emissions associated with an increase in pH in the ponds. The other emission that we're all concerned about, of course, is carbon dioxide, and carbon dioxide in the atmosphere is associated with acidification of the ocean. So my question is there a longer-term expectation that we'll see the pH start to decline again due to acidification from carbon dioxide increases in the atmosphere?
So the carbon cycle in freshwater is very different than in saltwater. With the prevalence of the dissolved inorganic carbon form. I don't know the answer to that. It's not something that I've heard about, as we talk about it all the time in the ocean now. So I'm surprised if it was as prevalent as it is in the ocean. I would think I would have heard about it, but I don't know the answer to that. I don't know enough about the carbon cycle in the freshwater. I know that the freshwater contains a heck of a lot more carbon than the ocean, organic carbon.
As opposed
So-
to dissolved carbon dioxide, though, in.
Right,
mean,
yeah, I
that's
don't
what
know
causes
how
it.
I don't know how dissolved carbon dioxide works in a pond. Sorry. I'm not gonna try to guess.
If we happen to live near one of these 1,000 ponds on Cape Cod, what would you recommend that would help us understand the health of the pond that we live near? What should we be doing to find out more about the health?
So there are a lot of, I believe, most of the health and conservation departments on the Outer Cape provide guidance on how you can take good care of your pond.
I'm not asking as much about the care
Okay.
as about the assessment
The
of the
assessment.
pond.
We have a town report that Ms. Moran will be talking about on the 4th, I believe, of June, a pond assessment for the town, but not of every pond, but
Right.
the larger ponds.
Yeah, so there's a town report that's been done on a bunch of the town ponds that Liz Moran will be talking about as part of the series. Do you know the date? June 4th. So there's more to learn about your ponds specifically. As far as what you might measure, I would say get involved with the citizen science monitoring that's going on in the town. There's quite a bit of it, and they're doing some really good long-term work. Yes, Sandy?
And
Yep.
I was just gonna answer that. We've been doing this for about 16 years. So if you live on one of the major ponds, for example, 10 of them every year, a couple of times. So if you live on one, we have a job for you.
Yep.
We're so always short on samples, and we are testing many different qualities. And that gets turned into some controlled studies and into SNAS. And you get reports back on the water quality.
Yes.
Thank you very much for an excellent presentation, and thank you for your service to the National Park Service.
Thank
It's a reminder of what an important investment it is to support the Park Service. But I guess I'm leaving with two takeaways that I think are sort of depressing, but I want to get confirmation before I jump over a bridge. The first is that even in areas that are relatively undisturbed, because of the increase in the atmospheric temperatures, the eutrophication process is already accelerated. And your modeling isn't yet definitive as to how much warming actually triggers an extreme worrisome case. But maybe you could give us your thoughts about, how much more addition before we reach a critical phase. And the second is that in areas that have been disturbed, where we know that there's already excessive phosphorus flowing in and other nutrients, you suggested that the increase in atmospheric temperatures acts as an accelerant, so that the extent of the problem isn't just bad because of all of the wastewater, it's going to be sort of like fanned forward and fast forward because of the increased temperature. Is that accurate?
Yes, sorry. I think both of those statements are accurate. So we do believe that under lower nutrient concentrations than we formerly saw them, we will see algal blooms. And for places that are already eutrophied, I think that we should still be shooting to reduce the nutrients going to those locations. And we are fighting against the warming. There's no question. Maybe warming will slow. I mean, that is the goal. And maybe and we are warming quite quickly here compared to other places on the globe. We're lucky we have higher rising sea levels and more warming, and so it keeps somebody like me very busy. But I think that it is a concern that we are sort of racing, or racing time. But I would say that our efforts are worth it still, because a healthier ecosystem is more resilient and more likely to be able to adapt. Because once you get into a state of extreme eutrophication, you have so few species left that you're not likely to be able to adapt to any more change.
I'm curious about the invasive species phragmites that seem to grow everywhere, and what effect they have on.
So they grow everywhere. They're a huge problem all over the Northeast. So they will outcompete almost all other vegetation. So it is something that we really tackle, is trying to get rid of it as soon as you see one. As soon as you see the stalk come up, tear those seeds off. So it will take a foothold wherever it becomes established. And it is a problem, and it will certainly outcompete all of the other shoreline vegetation. Yes?
While we're on invasive species, do you have a 3 or 4 invasive species that you would specifically see as being more problematic than other invasive species? Fish-wise?
I would say so far in our ponds out here, where we don't have major concerns. Phragmites is probably one of our most major concerns. Okay. I think that's it. Thank you.
Thank you very, very much. In 2 weeks, we'll have Brad Chase coming from the Department of Marine Fisheries to talk about sea-run fish. That's the herring that come in here to breed and then go out to live, and the eels who go down to the Sargasso Sea to breed and come in here to live, all the way into the pond right behind us here. So come on back in 2 weeks, and thank you again, Sophia.
Thank you.